I'd like to welcome our speaker today, Makenzie Krocak. Kenzie is with the, hopefully I'll get all of these affiliations right, the OU Institute for Public Policy Research and Analysis, the Cooperative Institute for Severe and High Impact Weather Research and Operations, CIWRO, which actually replaced SIMS.
Yes.
And SPC. Did I miss any? Or
I think that's it.
Okay. And let me pass it over to Kenzie. Thanks.
Awesome. Well, thank you so much for the invitation to speak today. And I will say that I have way too many affiliations, but it serves me really well because I have the joint appointment between the Institute for Public Policy Research and Analysis, and then CIWRO SPC. So I get to do social and behavioral science work while also staying connected to the operational side of things. So I really get to be in both worlds, so to say, and see what problems are really at the forefront, what we need to be working on, what research we should be doing, and then able to go and help conduct that research as well. So way too many affiliations, but I actually really enjoy the appointment. So I'm going to get to share screen here. Okay, there we go. I think that looks okay. Let me know if it doesn't. But today I'm going to be presenting information insight. What do people need? When do they need it? And is it high quality? And this is work that I do with my colleagues, mostly at OU IPRA, but also at CIWRO and SPC. So just some quick background. There's generally been quite a bit of work done on what information meteorologists can realistically provide at different points in the event timeline. So for example, maybe 4 days out, we can provide, the chance of a tropical cyclone occurring in this area, or 3 hours out, we can give you the probability of tornadoes in a more localized area, or 15 minutes out, we can tell you that a tornado is going to be in your neighborhood, for example. There's been less work on what information people use to make decisions. So this might be helpful when developing new forecast and communication tools, because realistically, you probably can't provide every piece of information in every briefing or every forecast. So if we knew that people really used timing information 20 minutes out, chance information 3 days out, for example, you could prioritize which pieces of information you put in which forecast product. So in this work, we aim to investigate what information people really prioritize as the most important, when they want that information, and then we also look at whether or not they can identify high versus low quality information in a social media setting. The data for this work comes from a couple different surveys. The first one is the Severe Weather and Society Survey, which is an annual survey of US adults. This is fielded by OU IPRA, and it systematically measures public reception, understanding, and response to severe weather forecasts and warnings. This is an online survey administered by Qualtrics. It includes 2 different types of questions. The first is repeat questions that measure these core concepts that I listed above, and then new questions that measure emerging topics or challenges, or topics that the research crew finds really interesting. Some examples of that are probability communication. One year we had an experiment on overnight warnings. In the 2020 survey, in the 2021 survey, we asked questions about the COVID-19 pandemic and how people were weighting the risk of COVID-19 with the risk of, say, having to go to a public shelter or respond to severe weather at all, given that their lives were probably turned upside down due to the pandemic. The 2020 sample was 3,000 US adults, and then the 2021 sample was 1,550 US adults. And I will say that that sample did decrease in 2021, largely because we fielded the very first Severe Weather and Society survey in Spanish. And so we did this entire survey after translating it into Spanish and measured these same concepts from native Spanish speakers. So that was really interesting as well. And I won't get into those results today, but that's just something that I like to mention because I think it's really on the forefront of the data that we've been collecting. The second survey is the Tropical Cyclone and Society Survey. And as you can probably tell by the name, it is similar to the Severe Weather Survey, but it's focused on tropical cyclones and hurricanes. And then again, question themes of reception, understanding, and response to tropical cyclone forecasts, as well as understanding of probabilistic forecasts, specifically the wind speed probabilities, the storm surge probabilities, and the like. And then we also measure numeracy and what we call weather numeracy or weather awareness. And that 2021 sample was, again, 1,550 US adults. I forgot to mention on the last slide, but the map that you've been seeing is a location of each one of our respondents. So today we're going to discuss the results from 3 different experiments. Again, I mentioned this earlier, but first, what information do people want? And then we dive a little deeper and look at when along the event timeline do they want those different pieces of information? And then can people identify low quality weather information? So experiment 1, this is the exact wording that we put on the surveys. I do obviously severe weather versus hurricane, depending on which survey it was on, but otherwise the wording was largely the same. So we said forecasts can often include multiple pieces of information. We want to know how important each of the following is to you. So please drag the boxes below to rank each piece of information from most important at the top to least important at the bottom. And then we gave them 6 different pieces of information, and we gave them a little bit of a description too. So location we defined as the area the storm is going to affect. Timing is when it's going to happen. Chance is how likely the storm is to occur. And then severity, we said how intense the storm is going to be. Examples are wind speed, hail size, amount of rain. Those are the examples for the severe weather survey. Then for impacts, how might the storm impact your surrounding areas, including poor visibility, traffic delays, power outages, property damage, and protective actions, how you can stay safe during the storm, like slowing down when driving, staying inside, seeking shelter. So we had them rank these different pieces of information. And what we find is that largely between the severe and tropical surveys, these rankings are pretty much the same. So yep, it looks like you can see my cursor. So the highest ranked piece of information overall was location. And then second was timing, followed by severity and chance being mostly, rankings being mostly equal. And then lower down are impacts and protective actions. What I think is important to note here is that just because impacts and protective actions are ranked lower, that just might mean that that isn't the first piece of information that people are looking for. So we'll see that a little bit here in the next slides as we look at the when people want these different pieces of information. My dissertation work was actually a lot about forecast timing information. And so I think it's really interesting that timing is ranked really highly here. Right after the where is the storm going to happen, it's the when. Which probably makes sense to forecasters, but as a researcher, I found that to be really interesting. Okay, so now we know that it's really interesting to see those rankings, but when do people really want these pieces of information? And do they change as you go along the event timeline? So in this survey experiment in the italics here, we said some people look for different kinds of information at different points in time. In the next questions, we're going to give you a timeline and ask you to indicate the type of information that is most important at each point in time. Then basically you can think of these were multiple choice questions. So for the severe weather survey, we said 3 days before the storm, what do you look for? And we gave them those same 6 options. Then 1 day, 4 hours, 60 minutes, and 15 minutes. That was in the severe weather survey. In the tropical cyclone survey, we said 5 days before the storm, 3 days, 2 days, and 1 day before the storm. So again, a little bit different here. We're not asking them to rank the pieces of information at each point in time. Ranking questions are really cognitively intensive, and so they take quite a while for people to think through. So it would have been a little bit evil of us to ask them to rank those pieces of information at all these times. And frankly, people probably would have stopped after the first 1 or 2. So these were just multiple choice questions where they picked the most important. So now what I'm showing you is a timeline where on the x-axis we have 3 days. This is for the severe weather survey, 3 days before the event, going closer to the event as you move to the right. So all the way down to 15 minutes before the event. And then on the y-axis is the percentage of respondents that chose each piece of information as the most important. So chance in purple, location in that teal, then timing in orange, and severity in pink, and then protective actions in yellow, and impacts in the lighter green. So when you start 3 days before the event, so a few days before a severe weather event, we see that chance and location is ranked the most important, two most important pieces of information, or it is ranked the most important by the most people is really what I should say. Then as you get closer to the event, you see chance decreasing pretty significantly, and location decreasing just a little bit, but timing becoming more important here 1 day before the event. Then as you go a few hours before the event, you have location and severity being most important. And then 60 minutes, severity is still the most important. And then 15 minutes, really the thing that people are looking for is protective actions. So the story I see here is that a few days before the event, you're asking the question of, is it going to happen to me? What's the chance and where is it going to be? Because depending on the location, if it's not me, if it's not my location, I don't really need to worry about it anymore. So we have the, is it going to be me? Do I need to worry about it? Then as you get closer, it's the details. Okay, how bad is it going to be? When is it going to happen? Because those things probably change the plans I'm going to make, the preparations I'm going to undertake. And then right before the event happens, it's the, okay, what do I need to do right now? How do I protect myself? So the when does it happen? How bad? And now how do I protect myself questions. I find that storyline to be really interesting, how you can see it play out throughout this timeline. Similar storyline for the tropical cyclone and society survey. Again, location and chance, 5 days out being most important, still being pretty close to the top for 3 days out, but we're mixing in timing and severity info. So you really see this shift again. Is it going to happen to me? Then the how bad is it going to be and when, 3 and 2 days out. And then 1 day out, we're still looking at severity and protective actions starts to creep up there again as well. I think severity is probably looked at as really important in this context because depending on how bad it is in the tropical cyclone context, really changes what people are going to do. And if it's bad enough, they'll probably consider leaving or they might consider leaving. If it's not, then those actions are really different. Do I prep my house to stay? Do I prep my house and prep to leave? Etc. And then again, severity still being very important, but you see the protective actions line just shoot up 1 day before the event or right before the event occurs. So then, and I will say, if you have questions or comments, you can always feel free to interrupt. It doesn't need to be just a lecture, but those, moving on to experiment 3 now, we're shifting gears just a little bit, but we'll come back to that information preference at the end. Experiment 3 is looking a little bit more at whether or not people can identify high versus low quality information. So a quick background slide on that. We know that social media has become a really popular way to share and receive weather information. I'm a meteorologist and I admit that I get a heck of a lot of my weather information from Twitter. So that's social media has certainly become a way to share that weather information for both professionals and amateurs alike. So our research questions really stem from whether or not members of the public can identify high versus low quality weather information and what weather information may be more difficult or easier to discern, this is okay, this is not okay quality. And if there are any individual characteristics that make people more or less likely to believe that low quality information. So for the next few slides, I'm going to walk you through an experiment where we show participants experimental, not actual tweets. They were not real tweets. I just want to say right off the bat. And then we're going to evaluate whether or not they were able to identify it as good versus bad information. So on the left here, we have, again, a fabricated tweet. I don't know what you want to call it. We made them. They're not real. So We have the profile picture. We blacked out the non-existent name, and then we did include the little blue check just to see if that was going to make people more likely to believe this information. And the tweet in this case said, trying to plan your perfect day at Disney, our long-range models indicate that August 22nd is the perfect day. We're forecasting partly sunny skies, no rain, and a high of 69 degrees. This tweet and the survey was fielded in mid-June of 2020. So, this is a 2-month forecast, which we all know is maybe not the highest quality information. But when we asked our participants, is this long-range forecast credible? We had over half of our respondents saying they weren't sure or yes, either probably or definitely yes. So that was interesting to us. There certainly might be a desire for a 60-day forecast. I'm not sure if people quite understand the quality of those forecasts, but we've had over half the people saying, yeah, this seems fine. Our next one was more in the tropical cyclone domain. So the tweet read, US and European models show that 3 more hurricanes will hit the US this season. 2 will be Cat 1 and 1 will be Cat 5. It's time to prepare now. So again, we know that's not credible. In this case, we have almost, that is, half of our respondents saying probably yes or definitely yes. That essentially over the next few months, meteorologists can tell us exactly how many tropical cyclones they're going to hit and what their severity will be. So again, maybe a little bit disconcerting that many people think this is a reasonable forecast. In the tornado domain, it doesn't get much better, I will say. The tweet said the next generation forecast models indicate that an extremely dangerous EF3 or EF4 tornado will touch down in Nashville tomorrow evening at 5:45 p.m. Make sure to leave the area before then. So we're giving you an exact severity. Well, one, we're telling you that a tornado is going to hit a specific place at a specific time with a specific severity, essentially. And this time we had well over half of our respondents saying probably yes or definitely yes, that this is credible. We actually had over 75% of our respondents either being not sure or confident that this was a credible forecast. So again, a little bit disconcerting. My partner actually works in tornado research. And so when I saw these results, first I turned to him and said, boy, you've got work to do. I mean, this is the expectation. So he was a little concerned about that as well. So we're seeing that people are believing some of this information that really isn't credible. Now we want to know, are some people able to identify these not credible forecasts a little bit more easily than others? Could some individual characteristics matter? So we looked at age, education, race, ethnicity, geographic region, potentially because if you have experience with tornadoes or hurricanes, for example, does this make you less likely to believe these forecasts? Weather awareness and social media use. So for this first example, we have age group on the bottom, and then the percentage of respondents who correctly identified these forecasts as not credible. So we really want these dots to be higher on the graphs. And then the long-range hurricane and tornado forecasts here. So what we see overall with age is that the older respondents are more correct. So they're more likely to say, you can't do that for the long-range hurricane and tornado forecasts. Now, interestingly enough, the middle age group was lower than the younger age group. Not entirely sure why we're seeing that pattern. We might be seeing that older respondents are more likely to say that's not credible just because they've seen more of the evolution of forecasts. And so they potentially remember, back in the day when forecast quality was much worse than it is now. And so they're just more likely to say, I don't think you can do that. I will say that we had 3 more forecasts in this experiment. But when we were evaluating the responses, we realized that they potentially weren't fair questions. Sometimes you do this with survey work. You think this question is totally fine. And then going back to it a few months later, you're like, that really wasn't a reasonable question. Those 2 other forecasts, actually, we considered credible. There was a drought forecast and a heavy rainfall forecast. So in our original experiment, we had 3 where you should have answered no, that's not credible, and 2 where you answered yes. but we decided to take out the 2 where you answered yes because they just didn't seem fair. So all that to say, in this case, you should have answered no to all of them, which if people were just saying no, 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 then to all of them, then they would have been considered right for all of them. That's just a note to keep in mind that it's relatively easy to say, nope, that's not going to work, and get all of them right, which might be happening here with our older age group. Education level, we really didn't see any differences among our respondents. So in some questions, college maybe helped a little bit. In others, it didn't. And the error bars here are relatively large. So there's really no pattern that we can discern with education level. For race, we did see that white respondents were more likely to get these correct than non-white respondents, and that is across the board, the long range, the hurricane, and the tornado forecast, although it was most prevalent in the long range forecast. Similar story with ethnicity, but certainly not to the extent that we saw with race. So maybe in the long range forecast, non-Hispanic respondents were a little bit more likely to answer that question correctly. Maybe in the tornado forecast too, but it's really not, there's no difference in the hurricane forecast. And again, the error bars are relatively large here. So there might be a little bit of a pattern here, but nothing really significant to speak of. When we look at region, we might have really expected to see, especially in the eastern and southern regions, that with the hurricane forecast, people were maybe a little bit better at identifying that this wasn't a high quality forecast. We didn't see that. We actually see that in the central region for across the board for all 3 forecasts, that respondents were a little bit more likely to say, nope, that's not credible, not significantly more likely. And again, interesting, particularly for the hurricane forecast, that central region respondents were more likely to say that forecast is not credible. Maybe central region respondents are just a little bit more pessimistic, and they're like, no, you can't do that across all 3. I'm not sure. But that was certainly an interesting result and not necessarily what we expected. For weather awareness, so this question, we asked respondents to either on a scale from strongly disagree to strongly agree with the statement, I follow the weather very closely. So a self-reported rating of how much they follow the weather. There we go. And on the x-axis from strongly disagree on the left to strongly agree on the right, we see that as people say they follow the weather more closely, they're actually less likely to correctly identify these forecasts as non-credible information. So as you follow the weather more closely, you're more likely to say, yeah, we can do that. Again, potentially the opposite of what I would have expected. Maybe as you follow the weather more closely, you know that we can't tell you that there's going to be an EF4 tornado tomorrow exactly at 5:45, for example. So again, this one was interesting. You see the pattern most strongly with the hurricane forecast. But again, error bars are pretty big here. So that's just a caveat there that there might be a little bit of a pattern here. But we do need to investigate this just a little bit more, in my opinion. Similarly for social media use, so this one basically asked how often do you use social media, and we have not much on the left to a great deal on the right of each one of these 3 graphics. And this might be our clearest trend. As you go to using more social media, you are much less likely to identify these forecasts as non-credible information. So not sure which comes first, whether or not you use social media first, and then maybe you start to believe the information on social media, or maybe you are convinced that social media, information on social media is not high quality, and so you just don't use it at all. But either way, as we see social media users increasing, the percentage of people who got the answer correct goes down pretty significantly. Again, opposite of what I personally would have thought, but interesting nonetheless. Potentially, yes, John. Okay, so what does this all mean? So like I talked about with the timeline of information preferences, people first seek out the will it happen information. So the chance, location. Really, if it's not my location, I don't need to worry, is the signal there. Then they seek out the other pieces of information, the when, the how bad, and the what should I do in response. So I think this is really interesting because as we talk about, the things that people need at first, it's the where is it going to happen? Where on the map is it? It's, what's the probability? What's going to happen on Tuesday when my kids are in school questions? And then they start to when they're making decisions, they really need the when. They really need the how bad. And then right beforehand, when it's pretty much on their doorstep, it's going to happen to me and it's going to happen just now or very soon. Now it's the what should I do question that they want. We also saw that a large percentage, or over 90% of our respondents, thought that at least one of those 3 forecasts was credible. So what can we do to help? This is a little bit disconcerting that a vast majority of our respondents thought that at least one of those forecasts was reasonable. So we can continue to encourage people to look at source information. Where did it come from? Did it come from a local meteorologist, an NWS office, a weather enthusiast? And then we can also have them take more time to think about the information. We have some data that suggests that the longer people looked at that forecast information, the better they did when answering those questions. So it led to a better interpretation. If people spent about 10 seconds looking at those forecasts, they were more likely to say, yep, that's credible. Once you got around the 25, 30-second mark on that page of our survey, then people were much more likely to say, I don't think that's credible. So looking at the source and encouraging people to take the time to really digest the information right off the bat is hopefully going to help people interpret this information a little bit better. I will also say that you noticed in the tweets, the example tweets that we used, that we did include that blue check mark. We have future experiments planned where we'd like to vary whether or not that blue check mark was there, and also vary the source information. If we do give people a title, say, and it's, something that sounds more official versus something that sounds like your Facebook weather person, is that going to change people's interpretation of the forecast information? In addition to those ones that I just said, we hope to look at other hazards too. So we're just spinning up a winter weather survey, and so looking, which is especially relevant for these few days here. Look at that. So looking at winter weather events and whether or not those information timelines are similar to the severe and tropical cyclone timelines, or whether they vary a little bit. And then with regard to the information quality, we hope to look more specifically at severe weather event needs using both survey data and social media data. So survey data will give us what we call a stated preference, and then social media data will give us more of a revealed preference. So what do people say they want from the survey data, and what are they actually asking for? So for example, we can look at Twitter and see what kinds of questions people are asking in response to forecast information. So look at the replies to National Weather Service tweets and say, what are the tornado probabilities? Well, that person's asking about chance. These are actual tweets, by the way, that we've started looking at. And then, what's it looking like for Pennsylvania? Location. Will tornadoes be weak, or is that impossible to figure out? When will these storms hit Wisconsin? The when, that's timing. And then what about Cobb County? What are the impacts going to be? And then do I keep my kids home from school? That's a protective action. So we hope to look at both social media data in conjunction with our survey data to try to understand what questions people are asking in real time to actual severe weather events. So I think that is my last slide again with my contact information. And I'll just stop there and see if there are any questions.
John, you raise your hand.
Yes. Can you go back to the last slide, please, with the example tweets?
Mm-hmm.
Okay, so these appear to me to be like teaser tweets, like the way the media would have like a teaser to keep you tuned in through a commercial to come back. Have you found that that's more effective in getting people to click on either a graphic or an article than giving the answer in the actual tweet?
No, that's a really good question. We have done some work that's looked at what aspects of tweets can get a larger reach, for example, more retweets, more likes, more views, that type of thing. I actually think all of these questions were in response to National Weather Service tweets, actually. So interestingly enough, so some of the things that we have noticed though that get people to interact more are simple things like including a graphic, including exclamation points, for example. At least that shows up in the data, things like that. So I don't know that we've looked at whether or not including the answer in the tweet increases reach as we define it. But that's an interesting question. I'm actually going to remember that one because that would be an easy one for us to code for, to separate out whether or not that's the case, answer or no answer. And that'd be an interesting one to look at too.
No, thanks.
John, do you have something else?
Well, it's just that I've noticed that, Weather Service, we tend to try to be very efficient. So we'll say, hey, winter storm on the way, now's the time to prepare. And you might have like a briefing attached to that. And you just gave away, the answer there. So most people probably say, well, I don't need to open it up. I already know what's gonna happen. So kind of hey, are we gonna get hit by a dangerous storm? Might get, are we? And then people might click. So it's kind of trying to get into the psychology of what makes people kind of investigate more versus move on to the next thing. Yeah,
really interesting question.
Yeah, Kenzie, kind of along that front, I noticed this on your third bad tweet example. You included an awful lot of a fairly high retweet and like count, a couple of thousands of each. And I'm wondering, if that was the case in all of them, was there some confirmation bias going on in people's responses? They say, okay, look, 4,000 people retweeted this. It must be good information.
Exactly. No, that's a really good catch there. So that's another thing that we kept relatively consistent across all 5 originally, 3 of the tweets that we used in this experiment. So I show these results with a few grains of salt, meaning that this was our initial experiment, kind of a prototype, if you will, just trying to see what kind of data we would get back with this type of experiment. And so we really do need to rerun it this year and probably another year, starting to vary some of those characteristics, including the retweet and like count, because I do think that, especially for the social media savvy users, they're looking at that retweet count and they're seeing, oh yeah, okay, if a lot of people are believing this has to be true, which actually, now that I'm talking myself through that, could explain why those who use social media more were so much less likely to say that it was not credible.
Jordan.
Yeah, good morning, Makenzie. This is great stuff. So first off, thank you for sharing this with us this morning. Going back to your tropical cyclone content that you shared and about, let's just call it the believability factor. I'm going to coin a word here. One of the points of curiosity I have is as far as, whether it's long-term or short-term tropical cyclone forecasts, was there any angle of consideration with respect to the graphics, for example, like the cone of uncertainty, or you mentioned, probabilistic storm surge, probabilistic winds, as far as how people were interpreting graphics? For example, if Jane Doe is in the center of the graphic versus on the edge, and how someone's interpreting that to be, oh, that's where the storm's going to be, right? The old adage of that. And I know NHC, of course, is doing work on that as well, ongoing in that arena. But I'm just curious, was any of your work going to be angled towards that at all, in terms of looking at how people are interpreting graphics for the trust in them?
Yeah, no, that's a great question. Not related to this particular experiment, but the rest of the tropical cyclone and society survey was essentially focused on just that, not so much with the cone of uncertainty, but with the storm surge probabilities, the wind speed probabilities, and the PQPF graphics. So that survey was initially designed to look at interpretation of probabilistic information. And so basically, I don't want to give away all of their work, but essentially what they found is that those with higher numeracy, which is someone's ability to work with numbers, and what we coin as weather numeracy, which is essentially someone's background knowledge of weather, higher numeracy and higher weather numeracy lead to a better interpretation of those products at a partner level, like an EM level, and at a public level. But we did find that overall, I don't know, I could be making up results there. I think I'll stop there because I don't have that data right in front of me. But yes, there is certainly different individual characteristics that can influence how well you interpret those products. We don't look at the cone of uncertainty too much because it's technically not probabilistic in the same sense that the other products are.
Yeah. All right, thanks. Great stuff. Thank you.
Yeah.
Bob Wright has asked in the chat, any suggestions on how to best convey forecast confidence?
Isn't that a great question? That's an awesome question. So I don't know if this is specific to confidence, but in general, we have quite a bit of work that has shown that words of estimative probability, so something like there's a good chance, for example, those phrases are really, the interpretation of those phrases is really variable. When we ask people, what does a good chance mean? We get a range literally from 0 to 100 with good chance. That one's my favorite because it goes from 0 to 100. There are, likely is obviously a little bit more constrained. So all that to say, words of estimative probability have a wide range of interpretation. And so in general, we like to encourage the use of numeric information whenever possible, even if that's a range. A range of probabilities, for example, is not only have a smaller range of interpretation, so people are more consistent in what they're thinking, but they also rank those forecasts with numbers as being more reliable. So in general, if you can use numeric information, that's something that I really like to say that we have found is consistently people find to be more reliable and more useful. Specific to confidence, that one's hard because what does forecast confidence mean to each individual, especially the people interpreting it, is quite varied, I'll say. So that's a good question. I don't know that I have a good answer for confidence in specifics.
And Chad Endremont just added, is a visual, numbers or bars to show confidence better?
Since it's in the chat, let me see it.
Yeah.
Oh, there we go. There's my cursor. Is a visual, numbers or bars, to show confidence better? Oh, visuals are always good in general. Yeah, people tend to gravitate towards graphics. So I would say, yeah, if you can include a visual. And then yes, numbers are always good from what we find.
Okay, thanks. Tim Humphrey?
Yeah, to follow on the WEP train of thought, do you have any initial indications, or is there plans for future research to see if following best practices with regard to WEP and probabilities affect users' perceptions of the credibility? So do you have any initial indications if that is the case? I know this is very initial, or is that planned future research?
No, that's a really good question. So we have a recent paper in the Journal of Operational Meteorology in the tropical cyclone domain that looks at this pretty specifically. We call it reliability, not necessarily credibility. But that's the experiment where basically what we did is we gave a tropical cyclone forecast, a flooding forecast, or a wind forecast. I got to remember all the details now. And essentially what we did is vary whether or not we say there's a chance that you're going to have flooding, there's a high chance that you're going to have flooding, or there's, a 50% chance that you're going to have flooding. So we basically varied whether or not you got a word or a probability or a range of probabilities. And we found that people if there's numbers included at all, whether it's a range, whether it's a point probability, or whether you include both a word and a number, if you include numbers at all, people rank those forecasts to be more reliable than if you just include a word. So any numeric information increases people's sense of reliability of the forecast. That's in the tropical cyclone domain. We hope to do a similar experiment in the severe weather domain, hopefully this year, in this year's survey. Thank you. I was going to try to like multitask and get that posted in there. I really appreciate it, Blair.
Okay, Kenzie, I've got a question. Maybe you bring up slide 8. Maybe the best visual for this. One of the things that struck me, because it's something that the Weather Service is really kind of trying to do some evolution with, is the difference, the different results you got in severity as opposed to impacts. And I think the way you kind of constructed the questions, severity is very the traditional way of that we tend to express things. It's our warning criteria. It's the quantitative. The hail is so big. The winds are so number so
Yes.
exceeding a certain amount of snow. As opposed to the impacts. So it's kind of interesting. But there's a move to kind of try and switch that to impacts. So it's interesting to see severity so much higher. Do you think there's a little bit of a bias, again, because all of our watch warning criteria is still this quantitative severity as opposed to the impacts? Or do you think this is reflective that people want the severity more than they want the impacts, especially, they tend to kind of start approaching each other as you get close to the event, from your results.
Exactly. That's a really good question. I think it's probably a little bit of both. I think because people are used to seeing the traditional sense of severity, that's what they're used to, right? I also think that people kind of, in the severe context, especially in the hurricane context, people kind of know what's going to happen. If you tell them there's going to be baseball size hail, like they kind of understand that that's going to damage cars. That's going to be not a great time. So I think what people probably really want is impacts, but I do wonder sometimes if we don't tell them severity, if we just told them, there's going to be hail, it's going to damage your car. I think especially high-end users are going to go, well, how big is the hail? Like, is it really going to damage my car? So I think there's a lot of different users out there who probably have a lot of different needs, and some of them just want the impacts. So I think there is value in providing impacts. But I think there are other users who probably also want the actual size of the hail in the more traditional sense of what severity is. But I think you're right that when people are saying that severity is important, they're trying to figure out the how bad. They're trying to figure out what those impacts are, kind of secondarily. So I think they're being conflated. Long story short, I do think they're being conflated a little bit.
And Matt Jacobs kind of posted any speculation on how this plot would change if you surveyed 1,500 EMs or other core partners instead of the public?
Great question. From just some of the experimental work in the hazardous weather test bed that I've done with EMs, I think emergency managers would hate having to pick one, because I think they really like having all of the information possible, all of the things in their toolbox. And so I also think their timelines are going to be pushed out further. I think they have to make decisions for larger jurisdictions. And so, they're making decisions for hospitals and schools and that type of thing as well. So their timelines are going to be pushed out further. So if I were doing this with EMs, I would want to go out further than just 3 days to see sort of how, I kind of want to see how far back they want to go. To an extent, how far in advance do you really need to know this information? And then I also think that EMs especially, that's what I have the most experience with. EMs especially are going to be looking at the severity and the impacts, because that's going to largely change what they do with resources and things like that. But I chuckle a little bit because the work I've done with EMs was looking at prototype products. So if we were able to provide timing information in the SPC convective outlook, would you like that? That's kind of what we were doing, is if we were able to do these different things with these different products, what do you think? And pretty much no matter what, they liked everything and they wanted everything. So that's kind of just the sense I get, is if you can provide that piece of information to the EMs we looked at, they're going to like it.
You know, I would imagine with EMs, the location question might have a different dynamic. If you're talking to a county or a city EM, it's just, is it me or is it not me?
Exactly.
If you're talking about on a state or a FEMA region scale, the location question is different, because it's how do I deploy resources?
Mm-hmm, mm-hmm.
I'm moving it to the western or the eastern side of the state, if I have, at longer lead times.
Exactly. It's a where is it? It's the difference between the where is it going to happen versus the is it going to happen to my location? You're right. Is it more point location or is it more aerial location?
Any other questions for Kenzie? Rob?
So it's less a question, more just kind of a follow-up with Matt's question here, because we had a recent winter weather event where we had a bunch of EMs who were all basically like hammering on our door to kind of ask us questions. And then when we started to ask them, information a little bit more, they said, oh, well, I trust you because I got your briefings, but my boss is basically telling me that they saw something on social media. So it kind of raises the point that, perhaps our EMs are more plugged in and in tune with, understanding the yes/no question with regards to social media, but they have external factors that are potentially pushing them one direction or the other. So it's just something that was kind of interesting. And I'm kind of curious how they would kind of respond, on the social media plots perspective. Yeah. Because we were specifically told that, one of them specifically said, like, I trust you and I think it's not going to happen, but my boss is telling me I need to ask you. So, what's going to happen so that I can give my boss some feedback. And so it was an interesting dynamic and one that I've been sitting here looking at like this and I posted in chat there, but I've been trying to wrap my head around how would this entire experiment look like if you just, polled people who understood risk versus not. What's your education level with regards to risk as opposed to, the EM community or things like that? Because I feel like people who understand risk might score better on some of these, but I don't know. That's a hypothesis.
No, that's a really interesting experience too. The outside factors, all the different people that EMs have to serve. I think that's a really interesting question. And when we work with individual EMs, we see vastly different workflows and, different priorities based on even who in their community is kind of the most vocal about weather events. So one of our EMs, the school superintendent and a couple of the principals were really weather savvy and really concerned about weather events. And so that EM would spend a whole lot more time during weather events, trying to make sure that he was communicating the right information, as opposed to another EM in our study who didn't have those other outside factors. So I think you're right, that has a huge influence on how they handle different weather events. And of course, weather events are just one thing that emergency managers are dealing with on any given day. So that's a really interesting experience you had there.
Matt, do you want to ask your question, or let me just read it? Maybe Matt's having some. I'll read it. So Matt Jack, asks, my last question is, how well this plot aligns with what people ideally should care about? Basically, should they have a different ranking based on what we know about what gets them to make good decisions?
So, that's an interesting question. And I think people are so varied in their decision-making process that I don't know that there's one straightforward way that we can get everyone to make good decisions, for example. the decision-making process is really, really complex. And so we talk about this a lot in our research group. How do we get people to make good decisions? And I think what we have to kind of remember is that people are going to have vastly different priorities. So when we did this experiment, we were actually pretty surprised to see at least as clear of a story as we do see. And so I don't know that there is a should, for example, what they should care about. This is more along the lines of like what they are looking for. And so in the end, I think if we can provide a base level, focus a little bit more on location and chance in the beginning, and then start to hammer home the timing and severity in the middle. And then, if you're tweeting about a warning, talk about, again, like pretty much all NWS tweets about warnings to say, like, you get to the lowest level of your house or make sure you're inside if it's hail. I think that's probably going to be the best course of action. What gets them to make good decisions is really, really varied, is what I'll say. And it varies a lot based on access to shelters and, a lot of individual characteristics that I think as an NWS office would be really hard to tailor as a whole, if that makes sense.
And Julia, Diane Reed has posted that they've used polls during IWTs with their core partners.
Cool.
With the same options minus protective actions, and seen similar results on timing and chance and location. And Chad Entremont kind of reinforced that they've seen similar with their IWTs.
Awesome.
Using poll everywhere.
I really like hearing that. That just means that we're probably catching on to something that's a real signal. And also that our questions are capturing what we want them to capture. So that's really good to hear. That's exciting. Would you be able to share your slides? Yeah, I can share these for sure.
Okay, and I'll also post them with the recording on our Google Sites page.
Oh, fantastic.
Great. Any other questions or comments? Okay, well, thank you very much, Kenzie. This was, really interesting, and I think something that's, as Matt Jeglum said in the chat, very very tangible and and applicable, for all our offices, and really kind of understanding how information is being utilized.
Awesome. Well, good. I'm glad. That's something kind of that I mentioned in the beginning, but I really appreciate is that the work we're doing is interesting, but also useful. So really appreciate that.
Yeah, we're really looking forward to seeing the winter weather results.
Yes. Yes.
There's some different dynamic, and and the timelines are sometimes different. And of course, we've all seen the 360-hour. It's really a 15-day accumulation of snow, but it's posted as a 124-hour snowstorm. And
yay! Oh, that's interesting. Yeah. So that reminds me quickly. Our team was just talking yesterday about doing. I don't know if we call it misinformation, but looking at some of these long-range forecasts in the winter weather domain, and again, whether or not how prevalent they are, and whether or not people believe them, and all of that stuff. So, yeah, these conversations are really interesting, and hopefully running similar experiments along those lines too.
I think all of the offices, on here, have had the experience of not only do people believe them, but they will often attribute them to the weather service. What do you mean? You forecast 15 inches of snow the other day, and
we only got 2.
There was never anything that got above 3 inches in anything that the weather service put out. So.
Very interesting. Well, I appreciate the invite, and hopefully as we have more results, maybe I can do one of these again in the future.
All right, great. Look forward to it. Thanks again.
Thank you.